Yeah, hello, I'm audible.
Yes, you're audible now.
Yeah, hi everyone. Uh, yeah,
Yeah, I
um,
already introduced you, so we can start with the your session.
yeah, sure. Yeah, sorry for the inconvenience caused from our end. Yeah. So, my name is Krishna. So, I work in Micron. So, to start off with, uh, you guys can chat, right? You guys can type, right? Uh, yeah, can you put a hi? Like, I want to have an interactive session with you people. Yeah, great energy. Yeah, that's great. Yeah, so yeah, I'm Krishna. Yeah, so I think almost everyone is using a smartphone, right? Out of all of you. So how many chips do you think like do you have in your hand? I mean, in your phone, how many different types of semiconductor chips do you think you have in your phone? Oh, okay, billions. Oh, greater than 10. Oh, okay. Oh, okay. Oh, nice. So, uh, do you know what is the most like? Can you tell what is the most uh, one which is making your phone to have a high value? Any phone to get a value to it. What is the one which is having more value? Okay, okay, yeah, great. Uh, okay, yeah, that's legacy ideally. Yeah, but we are here to change the story. You saw Apple phone prices getting increased. Have you seen that news? 17 Pro Max. Yeah, great. So we are the reason for that. Yeah, we are the bottleneck now. And one of the most expensive parts of your phone, that is memory. Yeah, that is where we work on. So yeah, I'm proud to be saying that I work in the memory. Yeah,
Yeah.
that is also an integral part, right? Yeah. So yeah, so I'm Krishna. I'm working in Micron right now, and I'm actively working in HBM verification. I joined as an intern in January 2023 here. I worked on different types of verification over here. Yeah, we would come to the questions. Yeah, just give a minute. Yeah. So then I started off my journey as a full-time employee over here as a design verification engineer. My expertise lies around DDR5, HBM, 4, 4E. That's how it goes. Yeah, till present. Yeah, we are actively working on all these things. Yeah. So yeah, I think you guys know a lot about memory, seeing what your questions are and what your answers are. Okay, great. Yeah, okay. Nice. Okay. So according to like what I have said, like I'm a DB engineer, design verification. Do you guys know why DB? Why we need DB? Design verification.
Oh, they are
Any
asking
idea about
what's
it?
DV. Okay.
Yeah, any idea for design verification? Okay. But okay, great answers. Yeah, chip functionality to test if chips are working as intended. Okay, fine, great. So, what do you think? Like, why DV? Why? I mean, why exactly? This can be done through multiple methods, right? You have post silicon validation also to test the functionality, or a designer himself can check what is happening in a block level or else with his own design by writing a normal test bench. Why do we have a separate uh, design verification rule? Great. They cannot cover all corner cases. That's a great answer. Yeah, Pratyesha. Yeah, that's great.
Reducing
Reducing
error
error and need to
early.
reduce
Yeah.
cost. Yeah. Great. Great answers. Yeah. Most of things, yeah, everything, whatever you have said is a true thing. Yeah. So it's like there is a phrase basically saying that people remember the company that launched the chip, but the verification team remembers the thousands of bugs that never reach the customer. So you got it right. So it's like We enjoy the HBM in different AI applications, but the HBM getting out from here, we know what all the things which are need to be corrected. Yeah, we are the back, we are like the back people which are there as a backbone support, not getting the issues get out. Yeah, so that is DV for you. Without DV, it is very difficult because each electronics uh, device is more of $1 billion sensitive. So you need a verification on a pre-silicon as to reduce the cost, as you have said. So that's one of the major thing. And not only this, can you tell more options if you have? Do you know like any more options like why we need design verification? Okay. Yeah, Naman, the answer what you have given is the correct one. Yeah, like that's also one of the major point to launch the market in the fixed time. Yeah, that is where again your verification comes into play. Yeah, yeah. So yeah, the goal of verification is to decrease the time not only in the post silicon but the time to market. So it's like the end part of your pre-silicon before going into post, which so it's like we are the gate which stop almost hardened uh, money leakage into market. So we would try to preserve the billions of dollars by reducing each issue. So that's TV for you. So that's what I work on. Yeah, that's my job role. And what I do, like what I work on is my daily friend. Have you heard any time about a 1T 1C cell?
Nope.
Nope,
Yeah,
nope,
I think
nope.
yeah,
Yep,
in
yep.
college we
Oh,
would not know these terms. Yeah.
yeah, so it's basically a one transistor, one capacitor, basically. That's what we say. So that's a fundamental unit of DRAM. Yeah, DRAM, yeah, that's great. Yeah. That's great. That's great energy. Yeah. So this DRAM is one of the cause like people just scold their phones because of hanging actually. That's also a major reason if your DRAM is not good. The phone gets hanged when you're talking to your important people, might be your boyfriend, girlfriend, or anyone else, friends. So yeah, we need to take care of that right before reaching it to you. Yeah, that's where your Micron does a good thing, like, and the memory comes in at a good play, a good memory, a good system, ideally. Yeah. So it's not only always the master processor to be faster, but the slave, which is the memory, has also to be a quick one. It has to be in a synchronized way. Yeah. So do you know what kind of products like Micron does? Micron builds. Any idea? What does Micron do in memory? We say memory, right? In Micron, what does memory? Yeah. Okay. Memory. Okay.
Like he's
And
asking
great
what kind?
answer.
Yeah, what kind of memory?
Yeah. Okay. Yeah, I'll come to that question. Why focus of HBMs? Yeah, I'll come to that question. Flash memory. I see a lot of NAND people. NAND fans more here. Okay. I'm a DRAM guy. But I'll be on the same note. Yeah. So, okay. Great answers. Yeah. So Micron is versatile and it's into different memory products. So starting from DRAM, your DRAM comes into play when it is used for your CPUs and servers or GPUs or AI, any like I mean short term AI things. And we have a subdivision of HBM, which we call it as using for which we use it for generally AI accelerators. Okay. And we have LPDDR, which is used for smartphones. We make memory for smartphones too. Your iPhone 17, the cause of increase of high price. We are one of the reasons. Yeah. Yeah. And yeah, don't scold us. Okay, fine. Yeah. We can't do anything. Yeah. So the GDDR, yeah, great. A lot of gaming folks. Huh? You guys know about GDDR? People likes GTA 6, waiting for GTA 6. Nice. Okay. Great. Yeah, I see a lot of folks generally talking about RTX, but not about GDDR. Yeah, your GDDR is something which goes into your graphic cards. So that's one of the major area where we do the business. And apart from that, we have our NAND solutions, as all you have been waiting for. And those NAND solutions, which you call as flash memory or floating gate, is something which we work on. That is also our product. And the most, one of the most area where we started and we are pitching slowly into it is embedded. Basically, we have embedded designs, which we actually do our devices for our embedded customers or automotive customers. There is an Indian brand, car brand, which is using our memory. Do you guys know that? Anyone happen to know that? Mm, take
Tata,
a guess.
Tata,
Come on,
Tata,
take a guess.
Tata, Ola, Mahindra. They're just randomly writing all the companies.
Less brands in India, so.
Yeah.
But Mahindra is the correct answer. Great guessing, huh? Okay. Yeah, so, but yeah, so Mahindra is, we support the infotainment of Mahindra. So Mahindra XUV, yeah, we have that being done. And yeah, so that's where your embedded comes into picture. Not only that, do you know that there is a recent deal signed with GE on this for Micron? Do you know? And yeah, so these are all the customers we have in embedded systems domain. And coming to the star of the show, HBM. Yeah. So always like HBM is, what do you mean by HBM? We hear a lot of terms, right? Like, yeah.
Where
Do you
is
know
it
what is
used?
HBM?
Yeah, yeah. Where is it used?
High bandwidth memory, crazy, huh? Do you have Google beside you or is
Of
AI?
course.
I'm fine if you use AI. We are most happier people actually if you use AI.
Yes. Use as much AI as possible.
Yeah. So great, high bandwidth memory. So what do you mean by bandwidth? Like we are talking about high bandwidth, right? What do you mean by bandwidth? Okay, frequency range. Oh, okay. Range of frequencies. Okay, tell me the small. A small doubt. That's a question. What is the difference between a throughput and a bandwidth? Actually, if you guys can tell. Go on. Okay. Okay. Channel capacity to get output. Okay. Okay. Great answers. Great answers. Great energy. That's great, actually. Yeah. Okay. But the point is, like, I need a difference. Yeah, Sri Charan, that's a great answer actually. Like, so your bandwidth is something like your maximum amount, which can tell you how much you can transfer, whereas throughput is actual amount, which can actually be transferred. So yeah, that I just wanted to ask this question. So we when we are talking about bandwidth, right? It's a major important thing. So yeah, that is bandwidth. Yeah, that's bandwidth for you. So why HBMs? Where are we using that right now? It's fine, Karthikeya. Yeah, cool. You're using AI. No, slowly you'll also get it. AI accelerators. Oh, parallel processing, matrix multipliers. Oh, okay. DSPs. Okay, great. Okay, tell me one thing. Okay, you are using for GPUs, TPUs. Okay, Okay, for GPU, if oh, okay, fine. Got the same question. IIT KGP. Oh, great, man. Fine. Okay. So tell me one thing. So if you say GPUs, right, you already have a GDDR, right? Why do you need a HBM? Why do you need a HBM for, if any chance, if you guys know any chance? Why do we need a HBM? Basically, if GDDR is there for GPUs. Okay. Okay. The answer is again bandwidth. Yeah. So it comes, yeah. So that's what. So this, whatever we say, this high bandwidth memory, right? So this is something which is very much important in terms of AI accelerators and whatnot engines you use, basically. So when you, like, from the day of when, like, neural networks were born to the day now, like, the advancements of memory will be going hand in hand till the day AI is there. So it's always, without memory, it will be difficult I'm not saying it would be the bottleneck, throughout or something like that, but it is a codependent thing with the processors. So it's always like you go hand in hand. So that's how your memory works. Yeah. So that is HBM for you, and I'm not going to stress you out with more details of technical things. Yeah. So that is where I work in. So we had a successful dice. I mean, HBM 3 has been shipped to Nvidia, and then we had a very good rating from them, and like it was superb. Like we had a superb review from them, and you see the stocks bloating up the high sky. So that is so it's so even though I talk about memory, so it again boils it down to your hardware basically. So as you see, rather than you have a software and all, yeah, it's fine. Your Google, software, or else your OpenAI, or else whatever it is, Gemini, OpenAI. What are all the platforms? Can you just tell me what are the AI platforms you use on a daily basis?
I use
Any?
Codex and Genie.
Oh, nice, nice. Okay, we are Claude fans.
Yeah.
Yeah, I see more Claude. Ah, yeah, great, great. See, I
Yes.
have more support. See. Yeah. So yeah, yeah, great, great, great. Grok, oh my God, Grok, nice, nice. Okay, okay, great, great. So great. So all these whatever platforms you call it, right? They are almost all the software accelerators we say, but they need a base on which they have to grow, right? What do they need? Software again. They need GPUs, and for GPUs to work, we need again uh, memory. That's where your HBM comes into picture. So in short to say, whatever day it is, whatever time it is, like with an advent of AI, from DDR we have come to GDDR to, like we have versatility of products, right? And to HBM till now. So wherever we go from PCs to servers to data centers or whatever we call, we always had memory in the hand. So that's the importance of memory in your life and in your domain. So memory is never going to die. It is going to be there. Yeah, obviously. So that's how like your HBMs are there. So do you guys know anything about DDR? What is DDR? Come on, man, answers. Come on. Double data rate. Okay, double data rate. Okay, fine, fine, fine. Okay. Great, great.
There's one
Okay.
dynamic
Yeah,
data
what do you
rate
mean by double
one.
data rate?
Yeah.
Do you know what is? So, yeah, yeah. Double data. Oh, okay. Coming. Yeah, fine, people. Yeah. So double data rate is something where you sample your data on the both edges of a pulse. As simple as that. It just increases your transmission speeds. The way you access your memory, your memory will be multifunctional now. It will be multi-cycle functional, and you can make transfers within compact cycles, compact pulses. So that generally what that increases your speed. In short, to say. Yeah, great. That's your DDR. Yeah. So this is one of the most important thing for our PCs. Yeah, so that's how your DDR works, and that's how your SBM works. I actually had a flow to show you people. I'll post it later through the channel or something. But yeah, right now we are having technical issues to share anything. Otherwise, I could have showed you. Yeah. So this is about me, and this is about my work. This is about the future of VLSI. So this is memory for you guys. Now you guys have any questions, you can ask me. Anything else?
Yeah, so what we'll do,
Okay.
I'll one by one, you guys can request to come on stage. I'll bring you on stage. You can ask a question, and then we can, proceed like that.
Sure. Okay.
Right. So
Cool.
let's start. So we have only one person right now. Okay, cool. Okay. Yeah, so you guys have to ask your question, then I'll remove you from stage, and then Agastya will answer.
Yeah.
Fine. So let's bring Prabha.
No. Hi, Prabha. Hello.
Yeah.
Hi, sir. Uh,
Hi.
very good evening, sir.
Yeah. You can call me Krishna or Agastya. Agastya is fine.
Okay, fine. I'm very happy to join this channel actually, first of all. And
Great.
what basically I wanted to talk to you is like I'm I'm graduated just now in May, I mean May
Okay.
2026. Right now I'm learning my skills like I have finished Verilog, System Verilog, and I'm gonna to like what do you tell learn UVM also. Like may I
Hmm.
know how the job market is in VLSI and how to get into the semiconductor industry because we didn't have any placement for core companies in our college as we are like from tier 3 college.
Okay. Okay. Yeah. Okay, sure. So basically, it's like it's great that you have come up to ask this question, and the amount of courses you have done, or it's great. So there's one thing, I mean, Prabha. So the point is like we generally it's all about the more about the projects and the more you showcase your skills, basically. So if you're trying to get a job, you have different approaches in semiconductor industry. It's not like, I mean, you have to have a specialized skill set. There is still a skill gap in the semiconductor industry, but all they need is skill. So for the skill, you have to like you can showcase that you have a skill by doing different projects, posting it on different social platforms. I mean, or else like you can, or else masters can be an option if you're willing to study. That would be a great opportunity. So you have to understand the industry. If it is a memory, you have your projects. If it is near to your any RAM based projects, design a 60 RAM cell or something like that. You find the power delay products and all, and you do the VTC. I mean, you do the curves and all. Yeah, so that is something, the characteristic curves and all. Then it's like you are exploring the RAM. Then it would be a higher pick, basically into your memory companies. So that's how you can get into the companies through internships or else through showcasing your skills. More visibility, more selection. Yeah, that's my answer. Yeah.
Okay.
And all the best. Wait about it. Yeah.
Yeah. Next is Karthik.
Hey, Karthik. Yeah.
Go ahead, Karthik. You're not audible.
Hello.
Yeah, he's not audible. Let's call
Hi.
someone else. So we
Ah,
have
man.
okay. There's no name, but yeah, someone is there.
Okay. Mm-hmm. Okay. Where is this? And what
H.
is the person's name? Okay, R03. Okay, great, man. Hello. Random Avengers or what?
Kinda, yeah.
Great. Okay,
Okay,
go on.
so I think I just joined some time ago. You were speaking something about embedded systems, right? So is it
Yes,
okay if I ask something related to the field of embedded systems and the job market?
I'll try. Yeah.
Yeah.
My, yeah.
Well, yeah, so I'll be graduating this August.
Mm-hmm.
And I've already been working on some stuff related to embedded systems, like, your basics in C++. I'm
Okay.
also doing some projects, also working on RTOS and stuff like that.
Oh, great. Okay.
Yeah, so I understand that projects are really important, but
Yes.
is there any specific thing that maybe recruiters look for that make me stand out from other people that will give me like a clear edge over other people apart from just projects?
Okay. Ideally, yeah. My role has been, yeah. Thanks for the question. Yeah. So ideally, my role is majorly into VLSI. I have been preparing towards a VLSI, but with my peers and what experience I had, what I understood is basically, yeah. So it's more like if you try to do something which includes all of this, like when you try to do I mean, it's all, right? The base is protocols. So the more you know protocols and in your embedded, the more it gets more. Uh, known. So that's your embedded. And you have, there are a lot of things over there, right? You have CAN, you have I2C, you have SPI, you have UART, all these things. It's not the way of how you simply implement it. It's how you introduce your different skills and apply and integrate it to a major project. That's how it works in anything. Even in embedded, when you talk about RTOS, like how do you apply your RTOS? You need to integrate. That's where your engineering skills come out. So the person stands out when he or she will be integrating 2 or 3 concepts to make a different project. That brings out the applicability from them. That makes them more recognized. So I hope answered your question.
Yeah, okay, next we'll have imperfect.
Hello, good evening, sir.
Yeah, go on.
Sir, I am seeking, I am interested in actually RTL design and verification. I am right now studying UVM. So, how much UVM, since it is a very broad spectrum, I wanted to ask that how much UVM should I focus since there are multiple things like UVM, RAL, and all.
Yeah. Yeah, I think there's some audio issue. He's just rejoining.
Agastya.
Guys, you can put in the questions in chat box also. If we, I mean, I don't think so. We'll be able to, accommodate everyone on the stage. But if the question is good, I can ask randomly in between. Startup in VLSI. Yeah, it takes a lot of funding, I'd say. Wait, just someone is calling. YouTube channel. No, he does not have. Wait. You joined now? Where is you? Where are you? Right to speak. Yeah. Fine. No, 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 it's good.
Yes, sorry, am I audible? Hello?
Yes.
Yeah, sorry.
Yeah. So the
Lot of
question was that to what extent should one get no UVM for a fresher?
Okay, great. It would be great, like, I mean, if you're taking any processor, for example, you have made a basic 5 stage pipeline processor, so you would write a test bench, right? I would suggest if you can invoke any UVM class into it or do a very simple operation on it. So it's like there has to be a basic knowing about how UVM classes are working, what are OOPS concepts, and how do your functional verification exactly work, and what if you do a assertion check, how does it work, and like that. You need not make it very much fancy by keeping different things. If you are at a college level and if you are trying to project your projects from your masters or your bachelors, this is sufficient. You just need to know the topmost layers of UEM, like basic UEM architecture, how your test and top are connected, and how what are your agents, what are your drivers, okay, how your interfaces are there. Just one example for each thing. That's all. You need not go deep and check everything. So yeah, that makes good actually. So one project implementation with simple UVM TB architecture. Yeah. RAL is something which is there, but you can use it. Like, I mean, if you are okay, I mean, if you are okay on sound and you have time, you can focus on that. But I would suggest a basic notation of RAL is sufficient. Yes. Yeah.
Uh, Hi, I'm Shashank, and I'm
Hi.
from a Tier 2 college actually.
Okay.
The thing is, I have done projects on risk by systolic array and P4 RTL to GDL, but I'm not getting
Okay.
an internship. And my another
Okay.
question is, are we allowed to wipe code in companies like Micron, AMD? Because I heard everything is sorry, it's all we should keep it a secret actually. All the stuff, the codes,
Yeah,
we can't
confidential
get.
use. Yeah, I mean, so the internal architectures always stay confidential, so we can't move it from there. So it's difficult to meddle with the proprietaries. Even when you're doing an internship, you would have an access to something very basic architectures. You would have access. Yeah, based on your seniority in the company, then you would have more view into the projects.
And how to
Yes.
get an internship, like in like companies like Micron? Like I have been applying for many companies, but I only got calls from which are training companies.
Okay, so yeah, you could either the point is it's simply like you have to stand out in different ways. So the more novel projects you work on, the more visibility you get at the same answer, you would get the more recognition over there. So your resume adds it a whole, and more importantly, your memory. If you can learn more about memory, showcase your memory skills, it's great. You would be picked. Next question, APB projects are enough. What is the scope and future of analog layout design as a function? Yeah, someone else.
Hello.
Sumit. Yeah, hi.
Good evening.
Yeah, good
Yeah, I
evening. Good
would be
evening.
in my third year. I have just completed my summer breaks. As of my
Okay.
course framework, I am done with CMOS, Verilog, and like digital electronics. This
Okay.
summer break, I studied a course from Maven Silicon, which was about RV32i based architecture, and I
Okay.
have made a basic pipeline project as well on this pipe. Also, I have made a Morse code encoder decoder as my project using system Verilog and Verilog. It runs on my
Oh,
Mac
great.
terminal only.
Okay.
But yeah, actually, my university, we are the first batch of VLSI, although it's an
Oh.
INI, and we don't have much clear picture about placement. But yeah, we have visited the Micron foundry recently because we are in Gandhinagar.
Mm-hmm. Okay,
So
great.
we
How
are
was it?
yeah, we were expecting Micron to come for placements and all those, but we don't have a clear picture in mind. And my
Okay.
aim is to get a foreign internship by the end of third year and to end up in a good company. So what
Mm-hmm.
should I do next in order to fulfill it?
Okay, so yeah, the projects what you have done on a scale, it's awesome, seriously. Yeah, you have to be I mean, if you need to have a foreign like internship, so there are few ways. One of the ways you get into any of the MNC, foreign MNC based company and try work hard and see if the chances are there to get there. If your team is there, you need to check whether the team is majorly based out of US, out of India, or else here in India. So that also increases your chances. That's one way. If not, there is this traditional way where you go apply in LinkedIn, showcase your projects. I mean, you put a post if you have done anything novel. Yeah, you can say it to the open platform people saying that, hey guys, I've done this. This is my Mac unit, or this is my processor. This is what I have done. So I have done the code converters. So you can showcase that. That's how you will again generate more contacts. It's all about connections too.
Yeah, one more thing to add, like you're saying about foreign internships, I feel right now it's really difficult because of all the visa situation. So I think you should aim for Indian, like whatever companies you have openings in India. Yeah.
Yeah, you yourself said that VLSI has come into your college, right, recently. That's so you can understand the need of VLSI in India more. That, and it's actually a good domain to flourish to in India. So yeah.
Yes.
Anyone?
Hello, am I audible?
Yes.
Yeah, yeah, yeah. There are two people.
So hello,
Okay.
okay, hello, I'm Harshvardhan Soni. Currently, I am a final year student, and I am more interested towards the physical design part.
Oh, okay.
Right. So, do you have any advice for me for next or 1 or 2 years? Currently, I am pursuing an internship in physical design.
Uh, I mean, I'm not of expertise of physical design. Your Sanchit sir is correct person to answer this.
Yeah.
Whenever he's available, you can flood up his inbox later.
Okay.
Yeah, thank you.
Okay. Thank you.
Why design? What is scope?
Hello.
Yeah, hi.
Am I audible?
Yeah, you're audible. Yeah, hi, Aditya.
I'm Aditya there. Actually, in my college, we are having two software, Synopsys and Cadence. I had some experience on that for basic circuits. So on that software, which projects will be getting my resume better? Which project should I choose? Alan doubt, sir. After 6 months, I need to get an internship on Taiwan. Actually, in our college, we are having too much relations with Taiwan universities. So they are giving opportunities to go there and work for an intern for major projects. So for that, I need to get my resume better and shortlisted first. Can you suggest me some projects to get shortlisted for it?
Okay. Primarily, what roles are being selected? I mean, that's what you need to decide. Sorry. Yeah. So if it is a DV role, ideally you can, like, as you're saying, like, you have an access or else you have an known knowledge of EDA tools. You can use any cadence tool, which is Virtuoso, SimVision. You can use it uh, more. Like, I mean, Verisium. So all these things which come under EDA tools, right? They give you a huge uh, scope for you. They'll make you that person who knows more of industrial things. So all these tools, we say Virtuoso, SimVision, and Verisium, these all things would be used inside the industries. So, and they are more advancing with AI. So yeah, knowing these EDA tools will help you in design verification. Yeah. Anyone?
Hello. Hello.
Hi.
Am I audible?
Yes.
Yeah, you're audible. Yeah.
So I have mainly three questions.
Yeah, yeah.
As you can see, AI is
Your
trending
name,
all
please.
over
Sorry,
the
sorry. Your
world.
name, please. Your name,
My
please.
name is
Sorry.
Nanda.
Okay. Great. Yeah. Hi. Yeah.
How
Go.
AI is impacting in VLSI and semiconductor, and can that replace any of the role in VLSI? I've heard that in physical design, like it's automating the repetitive task. So, is there any risk that it can replace any of the roles in upcoming futures?
Good question. So it's not going to be a replacement of any roles completely, because, right, electronics is something which is cost sensitive, as I've said. So one small mistake costs you billions of dollars. So and it is very difficult to make AI understand the way the things work completely 100%. There is an advent happening, which you can cover till almost 70% or 60%. But the point is, the critical tasks always remain with you. So, how much ever advent of I mean, AI comes into picture, it's not that your VLSI jobs will be going. It will be a change of jobs, basically. I would say that you would have more prompt engineers. You should know how to ask the AI what tasks it should do. That's the clever understanding you need to have. So if you have 80% normal task and 20% of a critical task, 20% of critical task has to be done by you, and 80% of normal task has to be done by AI. That's how you need to understand that. That's how you can decrease the number of hours in doing projects. That's all. That is going to be the change, but it would not create immediate or that high impact immediately. It could be a change of roles. Yeah. Thank you.
Hi, Agastya. Good evening.
Yeah.
My question is more from a person who's more experienced than a fresher. I hope that's okay. So, I've been in the industry for quite a bit, mostly in the medtech industry, electronics, electrical, and so on. I'm just curious to know if the experience that a lot of folks take from other industries like automobile, medtech, and so on, are there opportunities or roles for people like us to transition into chip? I understand it's obviously going to be a bit difficult because there's going to be a decent learning curve, but I'm just curious to know what is your opinion, and higher experienced folks in different industries, do they have a future in the chip space? Thank you.
Great question. So, first of all, kudos to you, because the thought you had of learning different things, transitioning between the domains, it's a great thought. Yeah, that's inspiring. So, not like thinking in your perspective, we need. You said you are from medtech, right? So, is it? If you are from the automotive domain and you have worked on embedded things, as I've said, there we make memory for embedded systems. Yeah, so embedded designs are very much important for automotives, and to transition into this, you need to come through a path. So there are few things like mechatronics and all, right, in US, not only in US, in Germany, and over here too. You have the GE basically giving in, and you have a lot of things like more. You have, as I've said, Mahindra. They also have a team with them for all these things. So that's how you can transition from your skill. That's where it helps you. So electronics is everywhere. VLSI comes everywhere. That's not going to be a thing which you can't remove. Thank you. Yeah. Hi. I'm also Krishna. Okay, fine. Yeah.
My name is Leela Krishna.
Oh, great. Yeah.
Currently, I'm in my third year.
Great. Yeah.
Like, I haven't done any internships yet.
Okay.
And to be sure, I just got to know I have an interest towards DV in front end. Like,
Okay, great.
design
Great.
verification.
Great. Yeah.
And what type of project should I have to do?
Great question. So, if you so I would not quote names to any project that this project is good and all. Uh, I would say my instance. So, I think Himanshi also might know. We had done a very small project called as binary to gray code converter, one XOR gate, two registers. You remember, Himanshi?
Yeah.
Yeah, that was a breaking point for me to get hired. So I have done process and all, but still, the point is why such kind of smaller projects. It's not about the size of project. It's about how much efficiently you're showing that your hardware and all is being used. Like when you try to write a code, make sure that, as you're saying, you want to go get into design verification. Take a design where you can have any FSM and make assertions out of it, or make any verification cases out of it. Test everything, improve coverage on it, get a coverage report on it. You can have a full layout of verification, how it can work from end to end. You can design the test cases, you can run that, including your with a design, and then you do a analysis debug, and then you do a coverage, and you can check. So it's like, take a design which has more number of permutations or combinations to check. So you can, the more number of states it has, the more number of exposure you get to verification, the more valuable your project gets. Yeah.
Okay, next we have
Hi,
Arnab.
Bobby.
Yeah.
Hello. Hi, Agastya.
Yeah, hi, hi.
I actually have two questions. First of all, I was being like, I have actually very low CGPA, like it's less than 7. So is it realistic, like for like trying for like the semiconductor roles? I'm currently in my third year, like just completed my third year.
Okay, okay.
Yeah.
And one more
Okay,
thing,
so
so like and realistically, like can I build some like decent like presentable projects for like companies in 3 months, 2 to 3 months?
so you want to do a project within 2 to 3 months, right? That's what you're saying, right?
Yeah, like realistically, like like my placements will be starting, so like with that perspective, I'm saying.
Okay, yeah. You can work on like the easiest way to do is, as I've said, FSMs are a very important one. Take any real life example or else take any small scenario. It's all about how you explain it and how you see it. You can take any design. You can take a lift, or else you can take a vending machine, or else you can take any other thing. But an FSM which has multiple state transitions, which you know, and then you can, when you're transitioning into it, write down the code for it. How do you do? And put some masala to it. Add some more cases where if some time sensitive things to it, so that if some time sensitivity is there to add, it changes to another state and all. So make test cases out of it. So yeah, that you can do. So take a small project, which is kind of like, as I've said, like code converters, binary to gray, gray to binary, and then you can add more complexity to it. Yeah.
Good evening, sir.
Yes. Good evening. Yeah, I'm Krishna. I'm Agastya. I've told you. Call me Agastya. Fine. It's
Yes,
fine.
sir. Okay, sir. Good evening, sir. I'm Vishnu. Sir, basically, I'm in final year. Sir,
Okay.
like, I have one doubt regarding this AI accelerators. While designing AI accelerators, you definitely, like, will check in the FPGA board. But in FPGA board, the memory constraint, like, constraint is there in FPGA board, like, it is around in bits. Like, how do you manage that memory? Because I'm planning to build an AI accelerator in Arctic 7 or Zinc FPGA board. So there I had a memory constraint to train that data sets all those things. Can you give any suggestions for memory adjustment?
I'm sorry. What was the issue you said when you're trying to build? Any? Okay. You can just type it in once. I just did not follow the issue. It was very long question. So
Memory issue he had.
uh,
So
yeah, but yeah. So I mean, like, I exactly like what I mean. What is the issue he's facing? That's what,
yeah,
like,
yeah,
memory issue. It's fine,
I'll
but
call him
what?
again on the stage. Let's take on the next one. Yeah.
Yeah, he can take the chat. I'll reply you. Okay. Yeah.
Yeah.
Yeah. Hi.
Hello,
Hi. Ash.
Agastya. This is Arshad.
Yeah. Yeah.
Okay, I'm audible, right?
Yeah. Yeah. Yeah.
So, I currently am like going into my fourth year. So, from past
Uh,
1 month, I've just started out my preparation in VLSI domain. So, what I've heard from all my professors and is that it is easy to get in the front end, but my
okay.
interest and where I have interest, it all lies in the back end. So
Okay.
I'm from a tier 3 college, so I don't expect any great placements also. But
No. No.
still,
Yeah.
do you
Fine.
have any suggestions for getting into this backend domain? Because I feel, for me personally, I feel that is more interesting. And for all the freshers out there, what do you think should be the most, I mean, what topic should they be strong in? And I guess that is that is only my question right now.
Okay, okay. I mean, like for backend VLSI roles, I mean, there are a lot in that. So, what do you want to go get into? I mean, uh, RTL. So, okay, let's think. Like, I mean, if you want to be a PD engineer, so you have to know more about like the PD concepts. Like, you have a type of different types of faults, or else you need to know how the clock tree is being routed, and you need to know all these things, like how routing happens and how the layout happens. and all these things. So this is something which you need to know in PD courses. And if you want to be an STA engineer, STA works more on sequential things, right? So your project has to be something which involves a lot of issues with your timings, a lot of flops. So take anything, you take any ring counters, or so you take any async. Not only this, you can take any LFSRs, I mean feedback shift registers, and you can try to introduce some STA into that, and you can show that it's how you're dealing with that. Your projects on prime time tool would be a very much addition for that. So the way you address projects should be towards that end. And very importantly, most important is the Verilog design you do. So you design an architecture that would be of great help. Yeah.
Yeah, one more thing to add, like in terms of getting into the industry, since back end roles are for freshers at least, it's very less. Like hardly people as a fresher they go into back end roles. So you can try for service based companies also, and then eventually move into a product based company. Yeah, that's it.
Yeah. So that's what the question is. Yeah.
Hello, Agastya. Hello.
Yeah.
Hello.
Tell me.
Am
Yeah.
I audible?
Yeah. Tell me.
So I had a
Go on.
question. Should I prepare for embedded roles, or should I go for preparation of GATE exam? What will be helpful for me in future?
Okay. Uh,
Hello.
I did not get. Sorry. Please repeat the question again.
Sorry, I'm wondering. I have a question. Should I apply for GATE exam?
You're not audible. You can maybe just put it in the chat. You're really not audible.
Hello.
Yeah. We have one speaker.
Yes. Hello.
Yes,
Yeah.
go on.
Am I audible?
Yeah. Hi.
Yeah. This is
Yeah.
Roshan this side. I'm third year student, VLSI domain,
Yes.
particularly this
Great.
VLSI domain. So I had a question about how much CGPA matter in off-campus internship and hiring, or they just reject people who have CGPA basically less than 7. And if it is, how to stand out for that? So this is my question.
Okay, so generally, if you're going through campus placements, then you would have that limit or bar. And I mean, almost every company has that, but there would be few more companies which don't have that bar. And so you can write those exams and get placed. But no, if you want to see for 7, like any company which is accepting greater than 7 CGPA, either ways you have to have a very good understanding, or else your your name should be highly audible, or else visible, or else resonated to the entire university. So that would make you more selective by the placement officer itself. That comes from what novelty you have brought in when you're doing your studies, your projects. I would say that.
Okay, Pratyusha, you can continue.
Hi, Agastya.
Yeah.
I am.
Hi.
Yeah. I have been
Sorry,
working in
I've been asking
Nashville.
your question.
Yeah.
Go
So
on,
I
sorry.
have been working. Yeah, sorry. You were saying something?
No, go on. Sorry, yeah.
Yeah. So I have a question. I have been working in Synopsys since last 2 years as an application engineer supporting Word.D and VCS, and I want to change my domain to a core DV field. I want to do some real-time projects of verification and all. In the backend, I have done APB verification using SV and UVM. So my question is, do we still need to have some more skills, or what are the skills that I need to have with me in order to go into a product-based company in a core role? I have not completed my MTech, rather I have just completed my BTech and then I am into Synopsys. But here as he is a is a role where I don't get a real time experience or a real time view to go and check into or get involved in a project. And I want to do that, and I don't get an opportunity even after applying a lot. So can you please suggest me some suggestions or something where I will be able to do that? So for now, I have done a project on APP and using SP and UVM. I have a basic knowledge on UVM and a good knowledge in SP. And I was mostly concerned or dedicated to digital field, front end field only. And in addition to that, I have also done a project on memory student Pygate transistor. So can you please suggest me some ways which will help me to come into the exciting roles that you are in? I can get a chance to look into the real time verification things, even after, like really what happens there, what needs to be
Pratisha, it's
done.
fine. Yeah, he'll just answer. We don't have much time, so yeah. Agastya.
Yeah, so you can, so ideally, as I've said, okay, so you said APB is your skill or where your experience lies, right? So you can do one thing, that is a very good place for the protocol, and you can try your projects integrating any memory to it. Like, I mean, when you take any, as you have known experience of that, you can take a CPU and you can take a memory, and you can build a system out of it with your experience into consideration. Or else you can take any design, ask ChatGPT or something else to have a basic design it can do, right? And you try to write test cases for it if you want to come into TV. So you leverage of what you have, and try to model your memory as a FIFO or with some exceptional data rates. Try changing those data rates, how you are flushing it out, how you're sending the data inside, and play with those timings. Like, that's how, once you explore things more, the more you play with the things, the more you get recognized, or the more you get deeper, the more you stand out. Yeah. Himanshi, I think we are about to have an end.
Yeah, last two questions. That's it.
Yes, Shaheen. Yeah, hi.
I guess, yeah, hope you're doing good. I just joined really late, so I'm not sure like what happened in the last couple of hours. But I have a very simple question. So basically, I'll just brief myself. So I'm currently working as a functional safety engineer in one of the automotive OEM called as Stellantis. But at the same time, I'm currently doing my NTech through BITS Pilani as a build program into a better system.
Okay.
And I really wanted to get into this VLSI domain. And therefore, like so far, I have completed my 3 semesters with around a CGPA of 8. And now I'm kind of interested into getting into this VLSI domain. And therefore, I thought I'll do some very serious project considering some FPGAs and SOC kind of architecture. Also parallelly, like I'm doing some NPTEL courses to get into more details of this VLSI aspects. For example,
Great.
the digital electronics topics and the variable.
I get it. So your experience, you said what?
So basically, I'm a functional safety engineer. So I'm into automotive safety. Yeah.
Yes. So great. So if you are on a functional safety engineer, and if you have a verification way through it, you have a lot of things which are in common between your reliability and the normal design. For example, UVM fault injection is a class which is very much important for ISO 26262. That's your functional safety verification. So you need to be very so as you have similarity between these things. The word you used, SOCs, right? That's a very good thing. So try to take an architecture. If you really want to come into design verification, take an architecture, write test cases, use your UVM fault injection class, what you have implemented, or if you have not, study it, and try to get it in synchronize with the designs what your SSC is having, and write down the test cases, do a coverage analysis. That's what I have to say.
Okay, so we have last question, then we'll wind up.
Yeah. Yes.
Hi, Agastya.
Yeah. Hi. Yeah.
So this is Rutvika, and I'm a recent BTech EC graduate from GNH Hyderabad. So I have hands-on experience in Verilog, system Verilog, ITL design, verification, and so my major project was mostly regarding integration of AES coprocessor with RISC-V, and I've completed the RTL to GDS2 implementation for it.
Oh, great. Yeah.
Yeah,
So what's it
so
all?
yeah, I've been reaching out to engineers and I've been applying for roles like DB or RTL, I mean the PD roles. And many people have told that I have good technical background and that is also strong. But I'm still finding it a bit challenging to land my first opportunity. Like, uh, I mean, it is hard to find the first one and also to get through the interview and the shortlisting process.
Okay. Yeah. So if you had any interviews, you can reflect back on what your skills, and what questions you missed or something. If not, like I would say the same thing. I mean, most of you had the same question: how to get into. As I've said, I'm winding it up. I have two ways. I have said one is through masters or at a top tier institutes. If not, you have to showcase yourself as much as possible in your LinkedIn's and your social networks. It's all about networking. So make novelty, create novelty. That is what people need. That is what I say skill gap. There are a lot of opportunities. All we need is skill. Proper skill, right time, right thing, right person will be picked. There are a lot of examples for a lot of companies, Google and all. They don't, like, it's not always they hire the top tier people. They can be people from different places, different experiences. It's all about the thinking and the exceptional thought which makes you stand out of the crowd. So try thinking deeper and create new test cases, novelty. That's all I have to say.
Yeah.
Yeah.
Okay. Thank you guys.
Thank
With
you.
this, we'll end this session. A huge thank you to Agastya for taking out time, and giving
Yeah,
back to the
thank you, Himanshu.
community. Yeah, sharing your experience behind the scenes, everything, AI, memory revolution, and everything. And thank you everyone for
Yeah.
joining. Hope you learned something new and you found this session valuable. We'll be back with more such sessions. Also, if you like this session, you can even tag us on the in LinkedIn and speak about it. How was your experience and all? So yeah, thank you everyone. Let's come back soon with yet another session. Okay, thank you. Bye
Thanks everyone.
guys.
Wait a good
Bye.
time. Yeah.
Bye.
Text me on LinkedIn if needed.
Yeah,
Please
yeah.
let me know
Yeah,
any
Krishna
doubt
is on
or in the
LinkedIn and
Discord.
Discord as well. So you can reach out to him under member section, mentor section.
Way to go, champs. Way to go, champs.
Yeah.
Always.
Okay,
All
thank
the
you
best.
guys. Bye.
Yeah. That's a nice fire symbol. Yeah. Thank you, Karthikeya. Yeah. Thank you, Himanshu. Thanks a lot.
Okay,
Yeah.
thank you. Yeah,
Signing
bye
off.
bye.
Thank you. Bye.